Hello, hello.
Happy Thursday, everybody. Welcome to season 1, episode 10. So uh glad to see everybody here. Can't wait to get people talking.
hmm
How was last week, Nick? Did you get to see the show last week while you were out?
Yeah, I did. I did get to see the show. I enjoyed it. I listened to it, and then I cut it for the podcast version. So
Yep.
if you want to listen, cloudfoundryweekly.com. I did notice that someone on Amazon Podcasts, I think, downloaded all 9 episodes at one time. So
Nice.
thank you for whoever did that, and keep listening. But anywho, yeah, I really enjoyed the show last week. I'm really looking forward to these Pokemon cards.
Yeah,
The CF push attack, 500 hit points. That was the highlight so
it-
far for last week.
that's what I was telling Tim. I was like, you need to market this. You need to get these out there. You need to every time we got a conference, bring in some new ones.
hmm
I think it's a great idea. We'll wait and see. Hey, Tim, prepare for your fight with Nintendo. It
Yeah,
should be fun to watch.
this is completely unauthorized, unofficial, unlicensed, sanctioned Pokemon cards. But
That's
anywho,
right.
yeah,
This
we
is Geek Stuff 101. We missed you, man. I mean,
yeah.
that was a fun episode. We went through an hour like it was nothing. I think we probably could have talked for another hour or two on that
hmm
show. And if we would have had you there, hell, we could have went 3 hours. So
Yep.
that was a good episode. And it's always sad to see you not there. People,
Yep.
you know,
Yep.
I don't know if you saw. So everybody, you saw the new intro. We've got a new logo coming out for Cloud Foundry Weekly. So when you're at Cloud Foundry Day, by the way, May 15th next week, be there. We're
hmm
going to be rounding out the show with a live episode at Cloud Foundry Day. But come look for us. We've got those stickers out there for everybody. But I'm getting a lot of comments back saying, "Man, you two look like brothers." No, we're not brothers. We're just both bald. We're just both bald.
Yeah, yeah. Oh, yeah. It's close. But
Yep.
yeah, shout out to Keith too. Yeah. So we'll post the link. There's a gentleman who we got referred to us from the Spring Office Hours crew who did the avatar. So he's pretty great to work with. I believe it's Reverent Geek, maybe David
Yeah,
Neal's the
so
name.
I'll put the link in. It's David Neal
hmm hmm
from Reverent Geek. I'll put the link in there. He's a great artist, worked with us very well, and did exactly what we wanted to do. So we'll put it out there, and anybody that needs it, go talk to David. I'm sure he'll be happy to hook you up. He does good work.
Yep. Yep.
Yep.
And
All
yes.
right. So this episode, again, this is going to be one of those things. This is right up your wheelhouse. This is your second nature. We're going to be talking Gen AI. We're going to be talking RAG today. And real quick, we'll get a guest to give it a little bit more, but give us an intro on RAG, Nick.
Yeah, so it's yeah, Retrieval Augmented Generation, and we're gonna have our guest here talk about that and how he's done a lot of work within the Gen AI for TAS space, in the cloud, really kind of making this more of a more realistic type of application and demo and use case here. So
Yep. So we'll
yeah.
go ahead and we'll bring him on. So our guest speaker today is going to be David Wu. So David is a senior staff product value engineer here at Broadcom, and he's got 7 years of experience with Pivotal VMware and now Broadcom with the acquisition. So he has a co-author of the book. If you've ever read Cloud Foundry for Developers, David helped us with that, and he is a PhD from Monash University. Hey, David.
Hey, Nick, thanks for having me on.
No problem. Anything you want to add to your intro there? I kind of gave an abbreviated version, but let's hear it straight from your mouth.
Yeah, I mean, look, I'm really excited to kind of share with everyone here, how we start our journey towards building this AI application using Retrieval Augmented Generation, RAG for short. So happy to begin.
Yeah, and first and foremost, we need to see your shirt because I think that has some OG swag right there.
Run PC,
Yeah, yeah.
Pivotal Cloud
Very
Foundry.
nice. Very
Look at him
nice.
sporting the OG stuff.
That's it.
Oh, and we're already getting comments, David, about how you're kind of the odd man out because you actually have hair.
I might be losing this soon with my 17-month-old, but we'll see.
Yeah.
Well, I like to tell everybody I'm not bald. My hair is just succumbing to gravity and it's falling down. So.
Yeah. I'll start using that phrase, Nikki. That's
it works out well. That way I don't have to explain, why nature hates me. So All right. Well, let's get started. So David, RAG, what is it for those that don't know? Tell us a little bit more about what RAG is and give us an intro on that.
Yeah, so let's just start with something really high level. It's a high level. It's basically an approach that combines the power of retrieval systems and large language models to generate more accurate and contextually relevant responses in our applications. So the way that it works is, RAG can retrieve specific relevant information from some database based on some user's query, grab that information, augment it into a query, and pass it over to a large language model to give us an accurate response. That's kind of the short of it. I've glossed over what a large language model is, so I assume everyone kind of knows, but I'll just say it. So large language model, I'm talking about pre-trained AI models, things like Llama 3, Mistral, GPT-4. These have already been trained to understand and generate human-like language. So if you used a large language model and tried to ask it about, I don't know, let's talk about very specific Cloud Foundry things, it's probably going to give you a irrelevant or maybe an incorrect response. That's likely the case. But if we can use RAG with it and provide it that information, it can actually generate a much more relevant response. And we'll see that shortly in the demo. So that's the power of RAG. We can quickly get an application running with existing data that we have. We don't need to train the model. We don't need to fine tune it. It just gets it going.
And to kind of break that down, so RAG, let's say, from kind of a common man terms, let's say we had a huge report on, let's say, traffic patterns of Los Angeles. We'd be able to ask it, hey, look at this report and give me, information and synopsis back on traffic patterns between 2012, 2014, right?
Yep, most certainly. Exactly. That's exactly the use case there.
Excellent. All right. Well, I can see where that would be, especially when we start looking at a lot of these companies that are doing huge document storage, the white papers, all of their documents, their financials. Is that a place where you could see RAG coming in to help with that, or are there more nuanced scenarios for that?
I mean, it would come down to whether there are any domain-specific things that it needs to know. It'll probably work in a lot of cases, and a lot of customers should give it a try since that's the most easiest route to actually get things going. You don't have to spend a lot of effort and money on hardware.
So, so do we see this as more as a public facing, or is this going to be more of like an enterprise internal chatbot type scenarios to help internal customers understand their document policies, like HR policy, right? That seems like that'd be a good use case. Hey, tell me what our policy is around internally.
Yep. I think it can be both. I mean, internal, those are two good use cases. I mean, internal is probably the best one because I think there's a lot of internal docs that everyone tries to look for information. My first day, how do I start? What do I need to look for? Things like that.
Because I remember there was a story, I want to say, I think it was one of the Canadian Airlines where they used a chatbot. Person went in and asked for tickets, and come to find out there was something wrong with what the chatbot gave, and they came back and said, well, we were using a public model, not a private model. But the court ruled and said, hey, if you're going to put this out there, and you're going to use this model, that's something that you need to think about.
Correct. That's right. And most importantly, how do you get observability into what's happening on the model? It's not just about let's build it and let's just put it out there and that's the end of it. It's really being continuously monitoring and improving it. You have to understand and validate some of the data that's coming through and actually be able to see what strategies are best to handle those edge cases.
Gotcha. Okay. Well, and what are some of the requirements that are required for RAG? We talked about pre-trained LLMs, large language models. What are some of the other requirements that customers need to look at if they want to go down this journey on their own?
Yeah, so you're going to need to have a database, something that supports vector databases. It doesn't have to be vector-based databases. There's different approaches to do RAG, but what we're demoing today is using vectors. So you get with a vector database, Postgres, which we have using today, and the GenAI tile, and that's pretty much it for right now.
All right.
Yeah, we did I did a very brief demo of some of the work David has done on episode 6 when we talked about TAS 6.0 with Cote. So I guess if you could always check that out too after the show, learn more about TAS 6.0. But do you want to get into the demo now, David, or how do you want to go next from here?
Yeah,
And
yeah.
then also we forgot our first question too.
Oh, we did. We always do.
We
that.
always forget the first question. So let's,
Ooh.
before we go to demo, what was your first CF push or experience with Cloud Foundry?
My first CF push.
Yeah.
God, that was like 8 years ago. It was like I didn't even know what Cloud Foundry was. It was like, what's Cloud Foundry? It's an opinionated platform. I'm like, what?
Mm-hmm.
I said, okay. I mean, we had CF Dev back then. I only had my laptop, so I said, okay, let's give it a go.
Mm-hmm.
I sent the CF push. I said, oh crap, really? That's all I had to do?
Yeah.
So that's exactly what happens. I mean, I used to help customers do a lot of app modernization, and they find it very hard to transition from I got to build my Docker environment, I got to do this and get everything ready before I get my app running. But CF push was like, wait, that's all I need to do? It's that same response. It's like, wow.
Yeah.
Friends don't let friends use Docker.
No. Yeah. Just see a push and you're in business, right?
Why would I want to learn how to do all those files when I can just say, here's my code, run it for me?
Exactly.
I don't care how, right? Exactly.
That's right. Keep preaching that.
Yes.
Yeah. And today's AI applications on Cloud Foundry is just the same. Here's my AI app, run it on the cloud for me. I do not care how.
Yeah. Woo. Yeah. We're working on this haiku stuff here. I think we're gonna be making some more shirts and things. Yeah.
Oh, absolutely. So, one of the things that we talked in there was, highlighting the domain specific knowledge that's used. Is that something we're going to get into the demo, or is that something you want to kind of explain out before we get into it, or do those in parallel?
We'll go down deep into the actual nitty gritties of everything as we go further.
All right. Well, man, let's pass it over. I'm excited to see this demo. Everybody loves live demos.
Yeah. Okay. So how do I?
Oh yeah, there should be a
present button right here.
Yep. Yeah.
There we go.
I think we'll have to bring your screen into stage once we see it here.
Okay, coming right up.
There we go.
There we go.
All right.
So, but before I jump in, I do want to give acknowledgements to Andrew Wood and Kevin Mackett. Thanks for all that AI discussions and a lot of the work that we did together to kind of clean out the data and building this whole entire initial work. So thank you so much. So first off, we talked about already that if we just went ahead and didn't use RAG, what would happen? So in this first demo, I've got an application here that's not using any RAG. And we can just ask it. Let's ask it about container metrics. Tell me about container metrics. And then just send it. Now, this is going to take a while because this is a non-streaming version. So when I say streaming, I'm in non-streaming. So non-streaming means I'm going to send a request through, wait for all the data to come through, and then present it to the screen. Whereas in streaming, I can give it the query. It's going to send me text by text. As soon as that data comes in, I can put it onto the screen. You'll see that in the next demo.
Nice. Very nice.
So over here, it's given something about container metrics. It's probably something about Docker maybe, but I don't know what topic it's about, and it's probably not relevant to Cloud Foundry. Not that relevant anyway.
Yeah.
So if I now go and switch over to the vector stage, which is the application that we have here today.
Oh, we got a new name for it. That's a pretty good name.
Got a new name for it. I had to have a name. If we got Spring Music, there has to be something else for this.
now we got to get a logo for this thing and graphics and we'll be good. So I like it.
So we have something with knowledge bases. I'll go into knowledge bases a bit more later, but right now, all you have to know is we've got the data from Cloud Foundry open source docs. And we can ask questions like, so let's tell me about container metrics. So here's the streaming in action.
Oh yeah, it's like Logaggregator Firehose. Yeah.
And there's a diagram.
Graphics.
Nice.
Wow.
And this is not stored. We didn't even store the diagram. This is an actual hyperlink to the Cloud Foundry docs. And again, we'll get into how that kind of came to be. I mean, in the last iteration of the demo, it wasn't showing it properly, but You know,
This app has gotten much better since I've seen it last. So very nice work, by the way. Yeah.
So the real difference here is generic answers versus scoped answers, right? The difference is, say, hey, tell me about Spring development versus tell me about Spring development on Cloud Foundry.
Yep.
So, okay. So you're just defining your answers by, I'm guessing, the knowledge base that you pick. Hey, this is going to be my scope of which I want the answers back.
Yep.
Okay.
I mean, there's a lot that you can do to this application. Like, I mean, heck, you could even say, oh, start detecting what type of queries I'm asking and direct it to the right knowledge base. I mean, we could do really fancy stuff.
Oh, wow.
Oh, get out of my head, David, because that was the other thing I was going to ask. If you do, natural language processing here, is it possible to say, instead of asking your question, tell me about container metrics and picking my knowledge base, tell me about container metrics from VMware OSS docs? Or
Exactly.
That's awesome.
Exactly.
I could definitely see use cases for this because I know I've got lots of questions and where's the best place to go get them? You don't want to dig through thousands of pages of documents to try to find that one little nugget you're looking for. Being able to do something like this that could pinpoint you right to the page and hell, even give you back the graphic that you're looking for. Man, that's powerful.
Yeah. I mean, this saves so much time. I just can get right to the information that I need.
Yeah.
Okay.
Yeah.
Oh, go ahead.
Oh, no, I was going to say the really cool thing about about this building this application was that I didn't have to worry about building a OpenAI REST endpoint, or build my own, and I don't have to worry about the backend code to interface with the large language model. This is already done for me on the GenAI tile. So all I had to do was, okay, because GenAI gives me an OpenAI compatible endpoint, I can use the OpenAI client to talk to it. Obviously, I'm not going to tell it to use that, ChatGPT 4 because that doesn't exist here, but I'm going to tell it what model to use. And all I had to do in the day was create the service, create a manifest to bind my application to the service, and see it push. That's it. Done.
That was going to go into my next question is we look at this application, and I know there's developers out there that are looking at it saying, okay, but did it take him a week? Did it take him a month? Did it take him a year to write this? Right? How long did it take you to get this working using the GenAI tile?
GenAI, I got something running within a day. It's not perfect. I mean, it wouldn't be in this iteration. I mean, this one took me, maybe a week because I was doing a lot of iterations, caring for a 17-month-old. Every night I only have like an hour or two.
Yeah.
dadding. But yeah, that's exactly it. I got it up and running really quickly.
So we've got a question that came up from Cloud Steel. Is this much different from a constrained Google search?
Is this much different from a constrained Google search? It's not going to replace. I don't believe it's going to replace Google because Google obviously has its special algorithms and everything to do a search. I think it's going to complement each other.
Well, and I think going back, and again, I am the least educated when it comes to AI on this call right now, but going back to what you said, if you use Google search, you're going to get a ton of answers back and you're going to have to kind of look through them, even constrained. Yeah. Whereas with this, it's going to be, depending on who built the application, what the back-end knowledge base is, it's going to be very specific to your internal company documentation, your HR documentation, or whatever that may be. So I get the constrained search, but I would consider this extra constrained. Is that a word?
Yeah. Well, I think too, when we're dealing with these local large language models, right? Because we're locally running them within our cloud. And I've been using one of my 3090 Ti's dedicated as a code assistant with something called continue.dev. And I've started, I would used to ask things to Google, how do I write this regular expression to do X, Y, and Z or something? And I can just ask that code assistant in my VS Code terminal, and it's going to give me it gives me a much better answer and a much tailored answer. And that's all just based on its knowledge of how to do things. So, but yeah, I think that's kind of what the difference we see between just Google and then some of these LLMs.
Yeah, I think it's a good question. And Google search, you'll end up with a lot of results. And this one, I can get very targeted to what I need.
Well, and I think you bring up a good point there as well, Nick, is local models versus the API public models. There is a lot of concern out there today with companies, worried that their people are going to go in and put in proprietary code, proprietary information into these models, and being able to use like the GenAI tile, which, correct me if I'm wrong, we can attach to some of these API driven models, but we can also, the real benefit is we want our data, we want to keep it secure, we want it within our data center. We know what's going in there. And I think that's one of the main drivers for a GenAI. Am I correct or incorrect in that?
Yeah, I mean, I think the containing your data and knowing where all those calls are going, and making sure that you're not leaking data out to some of these, I guess, open or third-party models. We've already seen multiple use cases where, like, so-and-so uploaded a bunch of documents into like ChatGPT, and then it started leaking out somewhere else. And I think nobody really knows where like these big open models are doing with all of this data that's getting sent up to it, type of thing. So, I mean, I think we've already started to see a lot of enterprises just blocking things like ChatGPT and some of these other things, like, you shall not. It's against the corporate information security policy, or intellectual property policy, that you just can't upload our IP to a random third party chatbot type of thing, because we don't know what happens when it goes there, type of thing. So yeah, that's the whole point. But with the GenAI tile, is to provide that experience for developers running on TAS, and so they can do something like David did and just not worry about any of the infra or any of that. Just start building your app and bind to the services and get something out there within a day or even a week, type of thing, versus you could spend weeks just trying to figure out the infra to build, type of thing. So,
well, and AI is blowing up. Right, everybody, they're putting AI in everything. LinkedIn's got AI. Everything has AI, and companies want to use it. But there are those security concerns around how you use it and what it's used to train the models, what is used to, to when you access the models, what kind of information is gleaned from that. Right. So I think that being able to balance that security aspect with the abilities of AI is very important. But using things like RAG, it gives you a real-time answer to questions that the company might otherwise take a day or so. Right? We got to call and get a hold of an HR guy, or we got to talk to our security policy people and wait for them to get back to us on a question. Whereas this can give people real-time answers based on the actual documents that the answers are coming from.
Yep. Yeah, that's the I think the goal here. So yeah. Where do you want to go next, David?
Yeah, so let's just kind of do some technical deep dive.
Okay. Yeah.
Go into it. But before we do that, of course, there's one more thing I want to cover, and that's we kept talking about it. Vectors and embeddings. You'll hear variations of it. Most people would say embeddings, and even I would probably be saying embeddings in the next few minutes. But to be more precise, what we're doing here is we're using an approach called dense embedding search in our demo. So what on earth is a dense embedding? So a dense embedding is just basically a set of numbers that represent information taken from a data source. So I have a diagram here, like kind of shows it out. Like I have a text, the cow jumped over the moon. We pass it over to some model called the embedding model. And it's actually not showing up on screen here.
Oh yeah, we're still seeing your Vector Sage screen.
While we're waiting for that to come up, we've got Sneal came out with another comment. I wish I could use this against a Slack data set to answer my own questions.
That's another project.
Yeah. I mean, it's possible, right?
It's possible.
Yeah, you just need somebody to write it, so it's possible. Get out there and either. Hell, I think look out for David on LinkedIn. Maybe David's got some ideas on that. I think that's a heck of an idea.
Yeah, definitely. There's some ideas brewing in my head at the moment, but we'll get to that.
Okay.
Oh, wow, you made slides and everything for this.
I thought it'd be easy with pictures. Would probably be easier
Yeah.
because my wavy and my Australian probably doesn't do justice.
Yeah. On a complete side note, David is by far our most prepared guest for this show. So
it was awesome. Didn't have to do anything. David
Yeah.
came out with, here's what we're going to do. Here's a line by line. It's like, man, I wish everybody could be that direct in what they want to talk about.
So what we have is we're talking about dense embeddings, and so we got the text over here. The big cow jumped over the moon, and we need to pass this text over to something, a processor, a neural net, or in this case, what we call the embedding model, the language model. So we pass it over to an embedding model, and this embedding model converts it into a bunch of numbers, which you see on the right-hand side over here. Now, as I said, this number is a representation of the information from the text. Now, what information are we talking about? We're talking about semantic information, contextual information. These embedding models have been trained to kind of extract that information and give you that number there. Now, on the other side, we've got a user query that says, oh, what animal jumped over the moon? We pass it over to the embedding model, and that also gives us a bunch of numbers. Now, these aren't real numbers. I made them up. Just a disclaimer. It was easier to do that way because generally these models will give us maybe 1,000 numbers, 4,000 plus numbers, depending on the type of model you have. Now, we can compare these two numbers, and we can use some sort of math around this. The most common approach is to use cosine similarity. There's other approaches and other ways of doing things, but most common, let's stick with cosine similarity. So cosine similarity, if anyone did vectors before, it's basically you're comparing, the angle between two vectors. Now, this is a two-dimensional thing, and I over here these numbers are in 4 dimensions, right? But for simplicity, the concept is very similar. You're finding the angle between the two, and you're going to get a number between -1 and 1. So 1 means that the content between the two text is similar, 0 meaning they're not similar, and -1 meaning they're dissimilar, they're total opposites of each other. Generally, you'd see that numbers are probably going to fall between 0 and 1 because most of the embedding models have been trained to push things in that direction. So by sticking these two vectors in, we can get a sort of a similarity score. So in this case, I got 0.878. So, okay. So with that, one thing that we need to remember is that you probably noticed that we're using the same embedding model. So I can't just go and use, one embedding model for the text and a different one for the user query and compare them both. At least that's the current, level of technology. I'm sure there's different ways of doing this later down the track. And why did I use an embedding model? And what's the difference between an embedding model and those Mistral models that we talked about? I'll cover that in a moment later in the talk. But for now, let's just jump now back into RAG. So as I said, RAG is 3 parts. There's the retrieval process, an augmentation process, and a generation process. So let's talk about the retrieval process. So the retrieval process, we assume that we've got a database already, and it's been pre-populated with content where we've calculated the embeddings stored in this database. Now, a user would come in and say, okay, what animal jumped over the moon? It goes into an embedding model, gives us a bunch of numbers, and we compare the similarity. Now, over here in this in our demo, we were using the Postgres SQL with vector support. So the cool thing is, there's a SQL query that says do cosine similarity between this and give me the top 10 order by descending, and it gives me the records like that. So similarity, 0.87, 0.56, 0.55, 0.31, etc. Now the second stage is augmentation. So from the vector database, it grabs the records, and I could do more things with these records. I can do more pre-processing. I can re-rank them. I can do filter out. So in this case, in this sample, I said let's just filter out anything that has a score bigger than 0.75. And then I grab that data and I put it into a prompt to say, give me the following information. Given the following information, the big cow jumped over the moon. Answer the query, what animal jumped over the moon? So that's the augmentation part. Now the generation part. So I've got my augmented prompt. I give this prompt to the text generation model, and that spits out a response to the user. A cow jumped over the bin. So that's that's how RAG works, really. Any questions so far?
We did get a comment from Sneal about, hey, good explanation. And, that was, you said we were going to jump into something that I was going to have the question. For those of us that are a little bit less educated on this, what's the difference between an embedding model? What kind of models are out there? What do you mean by that specifically in layman's terms?
Yep. So in layman's terms, so a lot of times we've been using large language models like ChatGPT. These are used for chatting. It is possible to use them to grab the embeddings out of these, but the output you get from a language model, from those language models, is text. You're not getting the actual numbers. And they're trained to give you the output, but not necessarily give you embeddings that are used to compare for this information that you want to use for comparison. In an embedding model, you've trained it already, and you're telling it, here's the text. Try extract as much information you can and represent it in these sets of numbers. And do things like, if it's hot and cold, try to move it in a location, in a position so that these vectors are total opposites of each other.
Gotcha.
Yeah.
Okay. All right.
Cool.
Well, I'm curious. What's the next slide?
Yeah.
I want to see what's on the next slide.
All right. So
keep me waiting, David.
Oh, I want everyone waiting. Roll the drums. So the next one is, so let's talk about the architecture of our demo app. So this is not the best way of how you develop it. I mean, this is a demo app. I didn't want to do too little, and I don't want to do too much to complicate things, but it's at this level. So we've got a microservice approach. We've separated out the UI. So basically the vector stage is what you saw already. And we've got a backend called RAG API. So the cool thing is I've separated. I can focus on putting all my keys to the GenAI service on this backend, and I don't go leak it out into the front. At least make it more secure in that sense. Both of these are written in Python, and the RAG API itself has a Swagger, which I can show in a moment. So the two models I have here are text generation and embedding model. So text generation, I've used a model called Mistral AI, 7 billion parameters. And over here, the embedding model, I've used something called HKU NLP, Instructor Excel. So what you might have noticed is, what are you talking about? So both of these are what we call instructor models. So with instructor models, I can give it instructions. So with embedding model, I can say, here's the piece of text. This belongs to a Cloud Foundry topic. Store it away for me so that I can use it for document retrieval. And then when I have a user query, I can say, here's a query for Cloud Foundry. Use it and generate an embedding that I can get documents from. So that's an instruction. Text generation, same thing. Here's all the context. Give me an answer based on the context. So that's an instruction again. So these have been trained to work in that type of form.
Okay. Real quick, we got a question from Findsy. Can you comment on the level of compute effort needed to generate your embeddings? Are we looking at substantial cost to embed large amounts of data?
Can I comment on the level of compute effort needed to generate your embeddings? So I'm trying to figure out how I can answer this. I think the hardest issue is you need a GPU. That's the number one thing. And for the embedding model, there's various sizes. And for this particular one that we used, it needed a 10 gigabyte minimum to actually get this running. There are smaller ones. You can look at smaller ones. And I'll probably recommend, going for something smaller first and seeing what that is like, rather than trying to go for, the best and end of the, whatever the optimal solution is, because you never know. For your application, you could get away with just using something simple.
Yeah, and I guess too to point out too, like in some of our previous demos, like in episode 2 where we did the Spring Music app, that was just using a singular model, so we weren't using this advanced method of breaking the embeddings and the text generation out of the model.
Yeah.
So like David's been instrumental working with the team to kind of help us develop this in the tile itself, and kind of go from there. So thanks again for your work on this, David.
No problem. Happy to help anytime.
Well, and I see that when we talked, based on our last GenAI episode that we did, there were some comments that came through, LinkedIn. People are concerned. We've got to have GPUs. Let's face it, GPUs are not cheap, which, by the way, me and Nick talked. If you ever want to tip us, we'll take GPUs for tips on this show. But, there is a concern for what the actual cost of this is going to be, small, medium, large, when we're looking at T-shirt sizes. Is there anything you can comment on that? And are there ways to iterate through, kind of stair step this? What do customers need to be looking like when they're going through this journey of implementing AI in their enterprise?
Yeah, I mean, for POCs, I mean, a lot of approaches with POCs, you can look at quantized models. These generally then you can start looking at using these with CPUs. And just seeing how that runs. It'll take a bit slower, but at least you can get something going. And then once you get a bit more advanced, you can then get into the GPU side and knowing what direction to take. There's that type of approach. Another approach that other people have been taking is going down the quantized model and then fine-tuning it with their specific knowledge. That's another approach that's been taken as well.
Okay. Well, and that's a good, you bring up a good point. GenAI tile, we've validated that the CPU usage is there. I think we've got, and Nick would like for you to talk about this a little bit, but we validated that CPUs, it's not going to be as performant, but if you're just starting this journey and you want to see what you could do with it, this is a good way to start before you make the investments in GPUs and you really start making the more complex models.
Yeah. So, we, on that kind of side, we've been working, Long and the rest of the GenAI team have been looking into CPU support. So I've just been testing some things this week with Long, and it looks like we have like a pretty usable, like we can replicate the Spring Music demo using the same Vicuna model, with some kind of new stuff that came out from Intel with additions to kind of optimization they made to some of the fast chat workers and things. But I mean, to that, we're hoping that's going to be enough of like a POC and a experimental type of thing to show, hey, this is what you can do. And it's going to be a lot better if you buy some GPUs. But a lot of our customers are like, hey, well, we want to do this, but we don't have GPUs. And we got to like justify the expense. And I totally get that. I used to be a vSphere admin. And back in the day, it was 6 to 9 months on a good time frame to get new gear, especially where you were on your budgetary cycles of like, hey, we'd like to spend hundreds of thousands, if not millions of dollars in new hardware. You got to like allocate that in a budget cycle somewhere, and then you got to wait for it, right? And currently what we're seeing, these higher end commodity NVIDIA GPU are not necessarily commodity. The higher end NVIDIA GPUs are quite rare and have a quite long lead time to get anywhere. So we've seen it in the public clouds where you basically can buy a pre-reserve or reserve instance and you'll get it like in a year. Or you can also wait a year just to buy one and run it in your own data center. So so we're trying to work through those, obviously capacity constraints. And I believe, correct me if I'm wrong, David, you are running both of these models on a single A40, A100, correct?
Yep.
Yeah. So David also was won the lottery, and somehow he got an A100 at some point in his career, and he still has it. He's also graciously let us borrow it for testing too. So I mean, I think hopefully maybe in a year or so, as some of these other Intel and AMD kind of play catch up, maybe we'll have not so capacity supply constrained environment for some of these higher end GPUs, but or maybe the CPU stuff will catch up. And there's this concept of like small language models and large language models now popping up, and maybe there are just valid use cases that we can through smaller models just run CPU on, and then the use cases that need the bigger models, that's where you dedicate GPU time to, where you have GPUs. Who knows? But
Great
Yeah,
use case for, doing MVPs, minimally
Mhm.
viable products. You got an idea you want to show your manager.
Yep.
You can do that on TAS with CPUs. Now,
Mhm.
again, I think, Nick, we might need to put out what CPUs we've tested against. Well, we haven't given an idea there, but to be
Mhm.
able to get that idea out there and show, hey, this has value. Now, it may take 2 minutes to run on a CPU. Imagine what we could do with GPUs, right? But it
Yeah.
give you that ability to talk to your management about how you want to implement AI, or your management has an idea and you want to kind of just showcase it and put it out there. It gives
Mhm.
you the ability to do that without the investment. And I think that's a huge important part, which I'm not sure we're really seeing a whole lot of in other places.
Yeah, I think too what we're seeing. So I have access to various life cycles or ages of CPUs from, and this is we're targeting specifically Intel CPUs, and I have like I don't know like a decade old. My home lab's running on some 2690 V4s, and I think it's I don't know how old that officially when the release date from Intel was, but I feel like it's pretty close to a decade now. But they seem to be running it. I'm try to get a table and maybe like a side blog on just some of our experiments with CPU. And now you may have heard too that some of these newer Intel generations, like the third and fourth gen, or sorry, the fourth and fifth gen Xeon chips have something called Intel AMX chipset, and that does seem to dramatically improve performance as well. So if you have any of those, you should. Those are also now becoming a very hot commodity, even in the clouds, as we found out this week of just trying to boot some of those up. So yeah, I think we could. I'll document some of my testing here, and then obviously they're not going to outperform these NVIDIA GPUs anytime soon, right? And there's going to be some use cases where they just can't even process or handle that. But I think definitely getting there for a POC to get the chicken and the egg problem solved. Of we want to do this, but we don't have any GPUs, so hopefully we can solve that with this.
Well, I do want to get back to RAG and what you're showing us here, David.
Mhm.
As we go in, this is all about getting context out of documents. So, somebody writes the app, but what is the back end management? I mean, there's got to be a document administrator back there, somebody that controls the document that's updating those. What are some of the personas and the people that are going to be involved in this entire process above just writing the app?
Yep. So a lot of these cases, you'd want someone who's probably going to know about the data, right? I think that was one of the biggest challenges in getting this working was the data. How do you clean up this data, pre-process this data? You probably in our situation here, we didn't need a lot of I wouldn't call it like a data scientist level type of thing, but at least it was just some level of data pre-processing to get this going. That's the nice thing about it. Of course, once you start getting into training, that's a different story again. Then you probably start wanting to get some sort of data scientist expertise to actually get this going. Yeah, so that's what we have here is a document administrator, and all he or she is doing really in this situation is just a user to actually create knowledge bases and upload documents. So a knowledge bases is just basically what I was just showing in the UI before. You can select, Cloud Foundry, or I can just create another one called baking, for example, and uploading documents. That's the kind of the high level of it. But there's a lot of complexity around this because when you actually upload the documents, right now the actual RAG API itself actually does something called chunking. So we don't just store the entire document in the database because otherwise you do a search, right? It's going to return to you the whole entire document. So tell me about container metrics. Oh, let me talk about PCF while you're at it. You don't want that to happen. So you want to be able to break it down into small chunks of text. Now, small chunks meaning, do I break it up by characters? Do I break it by sentences? But the approach we're taking here is we break it down by sentences. And we try to make as much as possible, sentences as long as possible, so that it contains enough context. So when I do a search for container metrics, it's going to pull out all the sentences that's talking about container metrics. And then I can kind of use that to give it to the text model to say, summarize it and give me the, answer it. So the question is, how do you select the chunk size? That's a bit of a tricky thing. We actually had to experiment a bit and kind of go, okay, let's try with a smaller one, see what happens. When you go too small, the problem is you get only portions of the information. You don't get the complete picture of everything. It was like, oh yeah, container metrics, here's one metric, done, that's it. But there's more to it, right? It's not just about that. At the same time, how can we make it larger? Now, we already know that there's an upper limit for the size of the chunk, because this embedding model, the instructor XL, told us that it was trained on 412 tokens. Now, a token is simply just your text, every word or every portions of the word that has been converted into a number, they call tokens, because obviously the models can only process numbers, you can't process the actual text itself. Now, with that, we know there's 412 tokens, and so we try to limit our sentence sizes to be below that, so that it gives us that optimal amount. There are other approaches to how you do chunking and how you kind of put all these things together. There's ways of like semantics that you can say, oh, grab all the sentences that are semantically related. There's algorithms like that, and there's algorithms where you can say, package all the whole entire document together and group together all the sentences that are similar. There's those types of approaches as well. But there's various of them. But the most important thing is start simple. Don't try to go do the optimum best. Just understand your data, understand what you're dealing with before you try to do the next step. There's as Kevin Mackett uses the word, there's a lot of knobs to turn. And your best friend is not to turn every single one of them.
Well, and that's where Cloud Foundry comes in well, right? Do that iteration approach. Start with a single thing and then grow it from there. And, Cloud Foundry, TAS, they're going to give you the ability to iterate on those things pretty quickly. So now, one of the other questions I have, and forgive me, this may be a stupid question, but I'm going to ask it anyway. When you're asking these models questions, are these models learning from the questions and the responses they get back from customers, or is that a completely different aspect of GenAI here?
Are they learning it? They're not learning it specifically. They're just using that and just inputting it. That's all it's doing, and processing it. If you
so let's take like ChatGPT, for example. Hey, tell me this. And it gives you back some information, and you say, no, that's not right. I was looking for something more like this. And it gives you back a better answer.
Yep.
Does the RAG models do the same thing, or is that a completely different type of AI generation?
It's all it's doing in that situation is it's sending back the previous history to the actual model. Now, in saying that, though, ChatGPT, when you do chat with it, each of those chat sessions become a potential training data set.
Gotcha.
And so this is something that you can do to expand your applications on. You implement observability, and you try to grab out the data. People will say, oh, thumbs up, thumbs down, this is bad, or this is good. And you try to group them together, give labels, and use that as a training data. We'll kind of go into that a little bit further, but you could take that approach as a hybrid approach. Like if you want to say, I don't really know how to do all this, I don't have enough time or money to go ahead and label all my data. So let's just get this RAG going, get all the information, understand it, and then let's figure out how we can train it.
Yeah, because I think that, me and Nick were talking about this yesterday with another coworker of ours. And, we were talking about in 2016, back when Microsoft released its AI model out on Twitter. And next thing you know, it turned, Microsoft's AI model turned into a racist jerk within 24 hours, right? Because the way things are going in.
The internet corrupted it in a matter of minutes. Yeah.
Yep. And they didn't use the word jerk, but, racist jerk was kind of the implication. But, I think that's one of the things that people kind of think about, too, when they think AI is, kind of that garbage in, garbage out. And what can you do to influence the models? And that was kind of the impetus for my question of, does it learn from you saying yes, no, or asking different questions?
Not without some sort of training or without at least some sort of previous context. That's another thing that I've added into this application with something called in-context learning, where you can provide it some additional prompts prior to the actual prompt that we augmented and say, okay, in context, this is what you got to understand. It's in context learning is like conditioning the model to kind of say, hey, this is how I want you to answer. do it in this format. So you do that by providing examples and say for example, I don't know, let's say you're picking a seat number on an aeroplane, right? You could do examples. The user's seat number is 11. What seat are they sitting in? And then the response will be 11. And then you do the next one. The user seat is 100. What seat are they sitting in? And then you provide the response as 100. And then you ask the final question. The user seat number is 500. I mean, that's 500 seats. The user seat is 500. What seat are they sitting in? And then the model should be conditioned to know it has to respond in that way. It will return 500. So it's things like that you have to do.
Gotcha. Findsy asked us another question, I think kind of related to what we're talking about. Have you considered using another model for response quality testing as you experiment with chunk size variations? Sounds like model tuning requires human scoring today.
Yes, exactly. I have considered using other different models, and it's actually changing so quickly. Like, while we were doing this, Mistral was one of the better ones, and suddenly there was another one. There was Llama 3 that came out. It just happened so fast. Have I considered? Yes, but we kind of stuck to it and kind of played with that for now. In fact, we started looking at different ways of generating chunks. I mean, do we manually do it, or do we pass it to a LLM to help us do that? That's another thing as well. There's just so many options to do this.
Well, I mean, Mark's question, nobody's seen the movie Terminator, right? Have we not thought of Skynet here? When Mark is asking, can you use AI to train AI? I mean, wow.
Yeah, I mean, I don't think we're. I think we're still far away from AGI or what is it, artificial general intelligence type of stuff. But
yep.
Yeah. Well, I think too. Another thing too is right. Like we're taking these like open source models, right? And then we can augment them with RAG and Postgres with our VectorDB. But once you take that away, they're just they're base open source models again.
Yep.
And yeah, shout out to Dan. Thanks for watching the show. Friends from Spring Office Hours here. Really awesomer generation. Yeah.
And we've got to ask, since Dan's here. So you were talking about Python. Did you use or have you looked at Spring AI? Any benefits that it would bring into something like your model?
Yeah, I mean, one of the benefits is that Spring AI. I mean, it's more of a Java focused over that side, and it's that framework that kind of helps accelerate the development of the application. Like some of it you don't have to worry about the talking to the database. I had to kind of in Python in this demo app. I didn't use any framework, so I had to kind of handcraft a lot of that. But if you use something like a Spring AI, or if you used Llama Index or something like that, they've already built that for you already on the back end. You don't have to worry about it, and so that's accelerating the enterprise productivity.
Nice. So I've heard you mention Llama Index before. Is that essentially like a Python framework for this?
Correct. That's another Python framework, and it's more focused on the RAG side. I mean, the other one is LangChain, which is more building.
Oh yes.
Yes.
Okay. Well, Dan, if you're listening, we would love to have you on the show to have a Spring AI version of this as well. So, yeah.
Yeah, absolutely.
Let us know.
People ask me, Spring AI, it's Spring data, but for AI models, right? Allows you to kind of switch between your AI models as quickly and as easily as Spring data lets you switch between databases. But I would love to see the Java version of this as well. Maybe have a showdown. David versus Dan, who does it better? Who wore it best?
Yeah. Yeah, I think that would be an excellent show.
Yep. Just do a 100% code off, right?
Yeah,
and live on air, and
I'll bring some popcorn and watch and provide I guess some banter and commentary. Well, I don't think I could compete though between Dan or David here for sure.
Yeah, do the WWE, and he comes in like John Cena.
Yeah. He's got a great keyboard. He's gonna be writing lots of code. Yeah.
Let's tap it away.
Yeah. Oh no, he's using a LLM to help him write it. Yeah, like no code assist allowed in this code off, right? Yeah.
Well, okay. You talked about frameworks there. We mentioned Llama Index. We talked a little bit about Spring AI. I'm kind of, I'm interested why I'm not seeing more from Dan right now on this, but what other frameworks are out there for developers to use? What are some things that they should be looking into?
Yeah, I think the main there's LangChain, there's Llama Index. These are the really top ones out there at the moment, and there's Spring AI as well. So these are the bigger ones. There are some smaller ones. I mean, one of the dangers of we have to be careful about is not to build a architecture, not to build something too rigid, because this whole entire area is evolving very quickly. And you don't want to use something that's suddenly going to tie you in very tightly into it. But you should be able to have some enough flexibility to kind of change things around when needed.
And what do you say the learning speed of this is? I'm a developer. I'm interested in AI. I mean, how hard is it to pick up like LangChain or some of those frameworks and start utilizing? Are there good places to go on the internet for somebody to get information on that?
Yeah, I mean, going through the demos that LangChain and Llama Index gives you, you can get something pretty quickly out, like in a couple of lines, you can get it running. But one of the really important things I think is, in my view anyway, in my opinion, is to kind of understand how this whole thing works before you kind of jump in. Because by understanding how things work, you can then understand what components you actually need to use in order to make a difference.
And are you doing anything? I mean, we've got Sage Vector out there. Are you putting that out for public use for people to take a look at? Do you have anything, samples that you might have out there? I mean, people would love to see those, I'm sure.
Yeah, stay tuned. I mean, there's a Llama Index version that's on its way, so that's working through there. I'd love to see, I'd love to see, or even start working on a Spring AI version. I mean, that would be fun too.
Well, you better get ready, because if we have our way and Dan comes up here, there'll be a fight on your hands. So, yeah. All right. Well, good. Well, maybe, after the show, again, we've got David's bio down in the show notes. Be sure and take a look at that. We've got his LinkedIn profile, which we're going to throw up here in a second. But David, if you've got any of those links that we could provide some of the listeners that they can go out and look at this stuff, if you could send those to me, we'll get those in the show notes, start getting people pointed that way. I think AI is a very interesting topic. And when we start talking about GenAI for TAS, we're making it very consumable for users that are already on TAS, especially with that CPU support, not having to necessarily run GPUs to get started. This is a really easy way for people to start learning about AI. Throw it out there, talk to your platform engineers, get the tile installed when we GA this. If you're interested in the beta, reach out to Nick on LinkedIn and let's see if we can get you interested and signed up for the beta. If you're if you want to do that. I don't see this going down. This is the new hot topic today, and this is not one of those things I think is going to peter out in a couple of months. This is going to be huge going forward.
Yeah, I think definitely too a shout out to David's team and his whole kind of org, right? So we can give you you can get the beta tile and stuff, but if you need help from a development perspective, we have a lot of experts here to help out from a Tanzu Labs perspective. So we have. We can help you there too in terms of you need some help from that development perspective. So,
yep, and we've got David Wu's LinkedIn profile. His link's also in the show notes below. But reach out to David if you got questions. If you always reach out to me and Nick. If we can't answer them, we'll definitely get you in touch with somebody that can. Absolutely anything that you guys have, reach out to us. If you've got something you want us to dive a little deeper into, let us know. We'll get an episode out on that as well. And we're coming up at the end of the hour, David. Man, great show. I learned a lot. Like I said, I'm the least educated when it comes to Gen AI, and you taught me some stuff today. Hopefully our audience feels the same.
No, thank you so much. I mean, really great questions here.
And look forward to maybe having you on again as you start, taking Sage Vector into a little bit more, complex model. Maybe we can come back and show the iteration and what you've done with it from then, or even some of the new projects you might be working on.
Yeah, definitely.
And then, but before we leave, we can officially announce some of our stuff we're doing next week. But are we ready to start plugging Cloud Foundry Day?
Absolutely.
Okay. Well, just so we have everything locked down from the schedule perspective now, and our speakers and panelists. So we will be back on a new time next week. So we'll be live. Pending no major technical issues, we'll be live from 4:20 p.m. to 4:50 p.m. on Wednesday, May 15th, Eastern Standard Time. We will be at Cloud Foundry Day in New York City, and we will be doing a panel session there. We will have Greg Otto, who's the executive director at Comcast. Comcast is a big Cloud Foundry user. We also will have Tom Briscoe from JP Morgan Chase, an executive director. They are between Comcast and JP Morgan Chase is two very large Cloud Foundry users. So I think really excited to hear them talk. And then we're also going to be live. I think this might be our first repeat guest, but Amelia Downs will be coming back. She was on episode 2 with us, and she is leading a lead contributor to the Cloud Foundry community. She's on the technical oversight committee, and we're going to have some banter between the users and contributors and see how we can get some discussion going on there. Amelia was actually at Explorer Las Vegas last year, and we had at the hackathon had some CF users and contributor conversation going on. That was pretty awesome to see. So I'm excited to see that next week at Cloud Foundry Day 2. So we'll be there. We'll have some stickers. Maybe our friend Tim will have some rare edition Pokemon cards to look out for. And we might even have some official VMware Tanzu swag to give out too. So it's going to be a good week next week. And
And don't forget, we'll be walking around. Nick and I will be walking around. We're going to have a camera with us, so we want to be catching all your Cloud Foundry memories. We want to be catching some of your CF pushes from the people in attendance. So if you want to be part of the memory montage that we're doing for CF, make sure you find us and make sure you get to tell us your story. We get it on camera. We'll wire all those together and put that out on the channel as well. I think that's going to be a lot of fun. And, one other thing, if you're enjoying this, make sure you hit the subscribe button down below. Feel free to leave comments. If we didn't answer all your questions, we'll get back to you. We are looking at those every day. So, subscribe, hit the notification bell. Make sure that you're catching all these, especially when we do things like we're doing for Cloud Foundry Day, where our episode time is going to change slightly from what it's used to. We want to make sure that you're out there. And keep a lookout for us on LinkedIn.
Mm-hmm.
David, anything you want to say before we head off and we sign off with our custom sign off?
Well, just want to thank everyone. I mean, it's been fun.
Yeah. Thanks.
Excellent.
Thanks for joining.
It was a great show. Appreciate it. And as always, CF, bye.
Bye.
See you later.